Hi guys, my name is Mrs. Jensen. I am a science teacher at a space camp in Ogden, Utah. And today I'm going to be talking a little bit about forces and motion. A force is anything that is a push or a pull. Using this ball as an example, if I push it, it moves. If I pull it, it moves. But what happens if I don't do anything? Will the ball ever move? About 500 years ago, a guy named Isaac Newton was really interested in forces and motion and how things moved and why things moved. And he started studying these things. And what he figured out is what we now have as 3 laws of motion. The first one is that stuff is lazy. It does not want to move. This ball will never move unless we change the forces on it. I could push it, as you saw me do, or I could blow it. I'd have to blow harder, much harder, but did you see it move a little bit? A push will make it move, and a pull will make it move. When those forces are equal or balanced, nothing happens. A good way to demonstrate this is with my friend Ralph. This is Ralph. He came to me one day and he said, "Mrs. Jensen, I have a problem. I keep falling on my face at school. My face is getting bruised. My friends are making fun of me. It's very embarrassing." So he said, "Show me what you mean, Ralph." So he stood up and fell over. It's gravity, that force, that pull towards the center of the earth. It was not Ralph's friend. So I said, "I see what you need, Ralph. You need a balance hat." His balance hat is made out of clay. Fastened it to his head and sent him back to school. Do you think that the balance hat worked? Let's find out. It definitely did not work. Ralph came back to me the next day and he said, "Mrs. Jensen, not only did that not help, but now my problem is worse. I fall faster and harder and I broke my nose." And I said, "Oh, Ralph, I'm so sorry. You said you were falling on your face. You don't need a balance hat. You need balance shoes." So I gave him some shoes. I did my best to make them the same size as each other. Do you think the shoes solved his problem? Let's find out. It did. He's a little lopsided, but at least he's not falling on his face. Why did balanced shoes help Ralph to stand up better? Because when forces are equal, nothing happens. There's not a change in motion. All of the weight or the pull of the force on this side of his body is now equal to the weight or the pull on this side. What would happen if I took off one of his shoes? We've changed the pull. It's no longer equal. He falls on his face again. Both shoes are important for Ralph's balance. Now that he is balanced, he will not ever fall down. Sometimes I like to use Ralph to practice my posture, to sit up straight, and to talk to aliens. They have not answered yet. Another way that we can see balanced forces is using something called a force machine. You probably have seen one of these before, but perhaps you did not know what it was. In order for this force machine to work, you will also need some electricity, and you'll need a ping pong ball, or cotton ball might work, something very light and airy. You could try it with a golf ball. You'll probably get very different results. Now, something that Newton figured out with this whole gravity thing is that when we drop this ball, it will fall down every time. Even if I throw it up, it eventually comes down until we introduce a force machine. Now, right here, my forces are equal. The force up from the force machine is equal to the gravity pulling the ball down. The ball will just hang out here as long as the forces are balanced or equal. Now, when you're doing this, you need to be very careful not to move your force machine around, because moving it is a little weird. Now, if you want to get really crazy, you can see if any of you are ninjas. Ninjas are able to do this, and the ball doesn't move. And before you turn off your force machine, see if it will work from the other side. Where the forces are equal, the push and the pull are the same. Nothing happens to the motion. We have balance. Send me your photos and videos of your Ralph experiments, of your push and pull your ball experiments, or see what you can do with your force machine.